Functional programming is essentially a kind of programming where functions don't have side effects. So what does it mean? When you call a function, you give it some inputs and it will return some output, and that's all that it does. It doesn't modify the inputs. It doesn't do something on the side. People often talk about firing the missiles. It can't do that. The entire behavior of the function you can see by looking at what the inputs were and what the output was that was generated. And if you program in that style, then functions are, you know a lot about their behavior. And many of the mistakes that are easy to make when you program in more conventional programming languages is that you forget about some effect that a function has in addition to returning its result. And when you forget about those effects, then they can lead to very difficult to find bugs and a lot of wasted time.
What do they get used for, these languages?
Quite a variety of things. They've made a lot of impact on the server side of internet applications. So, for example, Haskell, which is a language that I played a part in designing, that's now used for all the spam filtering on Facebook. Now, when I heard that, first of all, I said, I didn't think there was spam on Facebook. And Simon Marlowe, the man who's now in charge of this, said to me, exactly, that's how good we are. All of that is running in Haskell nowadays. Another example would be Erlang. That's another functional programming language, which I'm working with a lot at the moment. And Erlang was used to implement WhatsApp. Almost everybody uses WhatsApp at some point. That's all Erlang code running behind it. There are other examples. Twitter's code is built using Scala, which is a programming language that I think was heavily inspired by Haskell, but integrates very well with Java. But it's also mostly functional. And so, many of the services that we use every day are actually running functional code in the background.
You just mentioned then you had a hand in the development of Haskell. Where did you start? Did you have a big team that you worked with? Tell me about that.
Oh, so that was interesting. So when I first got into functional programming, there were a small number of people working on it at different universities around the world. And in those days, you couldn't really get hold of a functional programming language from somewhere else. You had to write your own compiler. So many of us around the world were doing that. And then after a while, we realized, and it was a man called Paul Hughes at Yale University took the first initiative to this, we realized that we were all working with very much the same kind of programming language, but because we each had our own compiler, we couldn't share any code. We couldn't share our results. And that just seemed like a waste of effort. So that led to the proposal to just take the common core of what we were all doing, put it together and design a programming language that we could all use, which became Haskell.
Where did the name come from then?
It's actually named after Haskell Curry, who was one of the early logicians who worked with lambda calculus. The first time that the committee that was formed to design the language got together, then we decided we had to choose a name, and nobody really knew what to choose. So everybody was allowed to write up one proposal on a blackboard, and then everybody was allowed to go around and cross off one proposal. Now, you might think that we would end up with 0 names that way, but no, there was one name that survived, and it was Curry, named after Haskell Curry. So that was fine. We thought, okay, the new language will be called Curry. And this was last thing in the evening, so we all went to bed, which meant we had a chance to sleep on it. And next morning, one of us realized that one of the abstract machines that was very popular at that time was called the Tim. Tim Curry?
How about that? Well, babies.
Oh dear, that wouldn't be good. And so we decided to call it Haskell instead. So it's still named after Haskell Curry, but his first name rather than his second.
From what I've seen, when you look at a functional program, it is very much like a mathematical equation. Am I right with that?
Yes, that's right. So one of the things is that, like mathematics, functional programs will satisfy what we call laws. For example, in mathematics, if you see x plus y, you can always replace it by y plus x, if that's more convenient. And in functional programs, then very often you may be able to replace one program by another. So you have different ways of expressing the same thing, and you can replace one by the other, which you may want to do because one of them may be much more efficient than the other. And you know that that replacement will not change the overall behavior of your program. So we find that these laws are extremely important for reasoning about programs, and they can let you rewrite your program quite freely in order to try and improve its performance, for example, and be sure that you're not introducing bugs.
I'm assuming that the same kind of mechanics are happening somewhere at some level on the computer as with any other programming language, though. Is there a payoff for this? Is it slower? Is it faster? What's the deal?
Oh, well, so functional programming languages take care of a lot of the implementation details that in older programming languages you have to do manually. For example, memory management. But nowadays it's very popular to use languages like even Java, for example, which builds memory management into the programming language. Functional languages do that too. Very often there is some kind of performance penalty for this, and that has meant that one of the very active parts of functional programming research has been developing compilers that can give good performance despite the fact that you're programming at a higher level. Nowadays, code written in functional languages can be as fast as, or sometimes faster than, code written in conventional programming languages. Well, one of the very nice benefits of functional programming, by the way, is that it's always safe to evaluate two independent expressions in parallel. And that's because functions have no side effects. So all the function's going to do is convert inputs to outputs, and you can have two of those computations going on at the same time. They cannot interfere. Whereas if you use programming languages in which each function may be modifying data somewhere else at the same time, then you can't tell whether or not two functions will interfere. They're very likely to. And that means that when you want to make programs run in parallel, when you want to make them use more than one of the cores in your laptop, then it's much easier to do that if you start with a functional program. And that can give a performance benefit over and above what conventional programming languages have.
I've heard as well that there is a possibility to make hack-proof code using functional programming. Is that something you could tell me about? Or?
Yes, so there is a lot of work in trying to make code that cannot be hacked, or, for example, can't leak confidential data. And there are people who are working on programming languages that will provide some guarantees about that. One of the quite successful approaches is to build a library into Haskell, in fact, that can be used for enforcing, in particular, privacy constraints. So yes, there's work going on in that area.
We're going to talk about things like your QuickCheck, and we've already filmed some stuff on that. What are you up to? What do you do? What's next for you?
So I'm devoting most of my time to QuickCheck nowadays, where the basic idea is not to write tests by hand because basically it doesn't work. Software is so complex that to make sure there are no bugs in it, you have to try all kinds of weird combinations, and there are just too many combinations to try for people to be able to try them all. So really the only way to ensure that you avoid these bugs is to generate tests instead. That's what QuickCheck does. It lets you write test code that says what your program should do, and then it generates as many tests as you want to check that it does. And I've been working with QuickCheck for many years now. 10 years ago, I founded a company that is commercializing QuickCheck, and that's been huge fun because it means I get to apply this technology to all kinds of real problems, all kinds of different kinds of software. And that's been a huge learning experience for me and a tremendous source of research problems when we find, oh, it's hard to apply it in this case. Well, there's a research problem to solve. So as a professor and a researcher, it's given me all kinds of new ideas for problems to work on, which has been very, very stimulating.
And the value of y at this position is going to be some polynomial that we have to find, which is a x cubed plus b x squared plus cx plus d. There are four unknowns here. X we know because we're going between 0 and 1.